Okay. Using a graphing utility, find the line of best fit. Graph the line over the scatter diagram. We will do this by hand, not by calculator. Does the graph look like a linear model? Does it look like a linear model? No. You know? And that's where visually, I kind of, if I were to connect the dots, he looks kind of curvy. So he's not going to quite be a linear model. Now, we want to know, is something a linear model? Remember, we did something like this. We called it first differences. And it says, if I go between here and here, it's 2 units. X is 2, X is 2, X is 2, X is 2. That's the change in X. Change in Y is 2. So 2 over 2 is 1. This gives me a slope of 1. Between 2 and 3 is 1. 1 over 2 is 1/2. So this tells us right here the slope between these two coordinate points is 1. But the slope between these two is 1/2. It's not the same. It's not linear. You could say it might be almost linear, but it's not linear. And you notice that if I were to do the next two, the slope would be steeper. So it's not linear. If essentially these were the same, it would be. It's not. It tells us that the slopes are not the same. So the data is not linear. Now that means that when I go to actually do it, I'm not going to have a perfect correlation coefficient. So now we get to do it one more time. Enter our data into the calculator. So remember, it is stat, edit, and since I have information already in there, I can just type over top of it. So put the x's in first. So 3, 5, 7, 9, 11, and 13. And then the y's go in. 2, 0. 0, 2, 3, 6, 9, 11. And then I make sure, knowing me, that these two columns line up. They need to line up. Because if they don't line up, I'm going to get an error message. Now, that doesn't mean I've typed them incorrectly, but they will line up. So now I want to do a linear regression. So I've got the data in, so it's stat. What do I want to do? I've already entered my data. I want to calculate. I want to do a linear regression. And again, this comes up. Now this enabled me, by the way, if I wanted to use another L value to put it in. I want to calculate. For those of you with the regular 84s, you won't have this. And there it is. Now notice what's R? 0.99. Now 0.99 says it's adjusting for where it's off. Now, is it still a fairly decent fit? Yeah, because it made up for the error in the data. So that says taking it to 2 decimal places, 1.13 and negative 3.86 is what I'm looking for. So what is my model? State the model found to the nearest hundredth. So y equals 1.13 x minus 3.86. What is the correlation coefficient to 5 places? 0.99073. What does that say about the equation I found that fits the model? How good is it? 0.9 or higher is a good fit. Perfect is 1. So we have 2 9s. So the model is a good fit. And how good is a question? It depends upon what we're trying to do. And let me get a picture up so you can see it. So this is going to drive me crazy. Now, if it's been done correctly, yep, it is. So I've got the regression equation in place, and there's the data. There's the line. You see, I've got a little bit of play on either side, and it says, that's not too bad. It's not too far off. Not bad.
I use the computer to print out my stuff.
You can't print in this room because the printer's not connected. Wish you could, but they've never connected the printer up once they redid the station.
Is there, should I just go to the library or something?
Yeah, that'd probably be the best place to do it. Might be the closest. I forgot to pass the roll.
Okay, cool.
And that's all his fault. You didn't do it today. Oops. Yes.
Did I not get the roll?
I didn't pass it.
Oh, okay.
You get to sign it twice tomorrow.
Okay, sounds good.
Okay, homework here so I can grade it and get it back to you. And then there's a stapler, and then pick up a test, and if you need scratch paper, take it.